Hello everyone, this is your junior high school math teacher and I'm going to discuss the fifth week lesson number 2 in Mathematics 9, and this is Proportionality Theorem. In this module or material, you would be able to apply the fundamental theorems of proportionality. Now we have the definition of triangle proportionality theorem. The theorem states that if a line is parallel to one side of a triangle intersects the other two sides, then the line divides those sides proportionally. Now, for us to understand such theorem, let us illustrate. Now, suppose we have a triangle here and the name of the triangle is triangle ABC. In this triangle, we have line XY passing through the two sides of this triangle at point X and Y. Or the line intersects segment AB and segment AC at points X and Y respectively, as you can see from the figure. Now suppose line XY is parallel to segment BC, which is the third side, then segment AX over segment XB is equal to segment AY, which is this one, over segment YC, which is this one. Now, to further understand the theorem, let us have an illustrative example. Suppose we are using the same figure, but the given are okay. So it is still assumed that this line is parallel to the third side of this triangle. So line XY parallel to side segment BC, which is the third side. Now suppose the length of this segment is given as 8 and the length of this segment XB is given as 3. The length of this segment AY, which is also given as 10, we're going to find the length of this segment YC. So basically, we're going to use or apply what we have just learned about triangle proportionality theorem. So for our solution, so that is AX is to XB as AY is to YC. So basically, we just directly substitute the given lengths of those segments to this proportion in order for us to compute for the length of segment YC. And this is the resulting equation. So, by doing some cross-product method, so the equation becomes 8YC is equal to 10 times 3. And your YC is simply what? 30, which is 10 times 3 over 8. Or that is equal to 3.75, which is our answer, or the missing length for YC. Okay? Next. Now, what about this theorem, the three lines cut by transversals theorem? This theorem states that if three or more parallel lines are cut by two or more transversals, then the parallel lines divide each transversals proportionally. So, if we're going to illustrate this theorem, we have this figure. So we have three horizontal lines that are parallel to each other, and they cut three transversals. Okay? And these are T sub 1, T sub 2, and T sub 3. Now, three parallel lines cutting three transversals. As you can see from the illustration, the number of intersections are 9. And these are point X, M, B, point Y, and points Y, N, and D, together with points Z, P, and F. So, based on the theorem, if these three lines, L sub 1 to L sub 3, cut T sub 1, T sub 2, T sub 3, or these three lines, then these parallel lines divide each of the transversals proportionally. So what does this mean? Okay, here goes. So if L sub 1, L sub 2, L sub 3 are parallel to one another, and these lines, horizontal lines, cut by transversals T sub 1 to T sub 3, at these points, yan, then segment XM over segment MB, the ratio of these two segments will equal to the ratio of the other two segments from the other transversal. So that is YN over ND, which is also equal to ZP over PF. Okay, so this is the equivalent mathematical statement for this verbal statement, which is the three lines cut by transversals theorem. Okay, now, to fully understand this theorem, let us again have some examples. Suppose we have segments AB and segment CD with X in between A and B, and Y which is in between C and D. Segment AB and segment CD are proportional if the ratio of segment AX to segment XB is the same as the ratio of segment CY to segment YB. Okay, so this is the illustration. Then, so if AX is to XB, this one, is equal to CY over YD, we can therefore say that segment AB is proportional to segment CD. Okay? So meaning the two segments are proportional to one another. Now, for letter B, so if AX over XB is equal to 1/3, this one, and CY over YD is equal to 2/6, then we can say that AX is to XB is equal to CY over YD by transitive property or by transitivity. Okay? Ayan. Now, if you have no questions, we go to the next slide for the next example, particularly illustrative example number 2. Now, given below are three parallel lines L sub 1, L sub 2, and L sub 3, which are cut by transversals AB, CD, and EF. Line segments AB, CD, and EF are divided proportionally by L sub 1, L sub 2, and L sub 3. If XM is 8, YN is 5, and ZP is 6, find the following. Okay, so this is the illustration. find MB if ND is 2. For letter B, find ND if PF is 3. Letter C, find MB if PF is 2. Letter D, find X if MB is 3X plus 1 and ND is 3X minus 5. Then finally, for letter E, if find PF if MB is X plus 2 and PF is X minus 5. So, let's begin. We go to letter A. So basically, we're going to use this proportion xm over mb, which is equal to yn over nd. Xm, replace it by its given value, which is 8. And yn is replaced by 5. Because the length of these two segments are given. Then mb, we rewrite mb since this is the one we're looking for. And then nd has a given value, which is 2. So this resulting proportion can now be solved for the value of mb. So by doing some cross multiplication, mb is actually 3.2. And this is your answer to letter A. Next. Now for letter D, we're going to use this proportion. Yn over nd, this one, is equal to Zp over Pf. Now, just like in letter A, both numerators have given values. And these are what? Okay. For Yn, it's 5. And Zp is 6. Then, and this is the one we're looking for. So, we just rewrite that term, that segment. And Pf has a given value, which is 3. Okay? That it is declared in letter B. So in this case, this resulting proportion can now be solved for ND. So again, by doing some cross multiplication or cross product method, you will find out that ND is what? Is equal to 2.5. Okay? Next, letter C. Now, for letter C, MB, what is MB if PF is 2? So, basically, the proportion we're going to use here is XM over MB equals ZP over PF. And then we substitute the given segments, the value for the given segments. So, XM is 8, ZP is 6, MB is the one we're looking for, so we just copy, and PF is given in letter C as 2. So, this resulting proportion has a missing term, which is the value of MB. So, by doing some cross-product method or manipulating this proportion, we can compute for the value of MB. Okay. So, that is MB is equal to 2.67. Okay? Next, about letter D. Now, these are the given, and what would be the right proportion for that? XM over MB, this 2, from this transversal, equals what? Yn over ND. So, taken from this transversal. And then substitute the given lengths. XM is 8, then MB is quantity 3x plus 1. Then Yn is 5, while ND is quantity 3x minus 5. So, we have now a proportion in terms of x. So, by doing some cross-product approach or cross-multiplication, we can find the value of x. Yun. Then, distribute 8 inside the parentheses. Same thing with 5. You distribute 5 inside the parentheses. And at this point, the equation is 24x minus 40 equals 15x plus 5. Okay? Manipulating the equation further. So at this point, the equation becomes 9x equals 45. Then divide both sides by 9. So x is equal to 5. And with this obtained value of x, we can compute for what? Segment PF. For the length of segment PF. Actually, we don't have to look for the length of a segment because letter D is just asking for the value of x. Okay? Yan. Now, we go to letter E. So, these are the given. So, the right proportion for letter E is xm over mb is equal to zp over pf, taken from these two transversals. Okay? Then substitute the given lengths. xm is 8, then mb is x plus 2, while zp is 6, and pf is replaced by x minus 5. So the resulting equation can be solved for x. So we do the same thing. We apply the cross product process. So the equation at this point becomes 8 times the quantity x minus 5 equals 6 times the quantity x plus 2. So the equation becomes 8x minus 40 equals 6x plus 12. So at this point, we have 2x is equal to 52. Dividing both sides by 2, therefore our x is equal to 26. And from this obtained value of x, we can compute for pf by plugging in the obtained value of x to this expression. So pf is actually 26 minus 5 because x is equal to 26. Therefore, pf is how long? It's 21. Okay? Now, suppose although MB we letter E is not asking for the length of MB, but anyway, we determines the length of MB as well. So that is actually 26 plus 2 and that is 28. Okay? Now, now at this point, I am done discussing this topic. So at this point, uh, I'll end the discussion and we'll see you again next time.